So in this part of the lecture 7, we'll see RC circuit in discharging mode. Okay, so this is again a similar kind of circuit, but just to complete the whole process of different kinds of RC circuits, we'll see how this discharging circuit can be analyzed. So if you see here, this is a voltage source which supplies, and this is a switch arrangement here. And in this switch arrangement, either this RC combination can be connected to voltage source, or it can be connected to this ground. Okay, so these are the two options. So when the switch is connected to the source side, that is V is connected to it, then this capacitor C is allowed to charge, and it charges up to a certain point. So if it is kept for a very long time, at the most it will be charged up to point V. So assuming that it has been kept there, the switch has been there for a longer time, so it charges up to point V. So it is VCO becomes equal to V, and it is set to be pre-charged up to VC. And when it is thrown to this position at t is equal to 0, then you see that this VC RC arrangement is closed like this, and a current flows because C has a charge on it. That means it has a voltage on it. Okay, so in that conditions we can analyze the circuit when the capacitor is pre-charged and it is discharged through a resistance R. So for that particular circuit, that is on the RC circuit, where capacitor is pre-charged at V, and this is the circuit we have. And for this circuit, if you wish to write the equation, Kvl equation, this comes out to be Kvl equation. So IR plus VC is the voltage across the capacitor, and IR is the drop across the resistance, and this both has to add to equal to 0. And this is again you get is first order differential equation, which you can solve in the same way as you have been doing earlier. Okay, and on integrating this differential equation, you get this one. And here important part is you evaluate the value of k in the conditions given now. The solution is almost similar for all the RC circuits, only the difference is the difference is in evaluating the value of k, which is done at 0. So at t equal to 0, VC is equal to V, that we have seen. Okay, while putting to 0, the capacitor is fully charged at to V at t equal to 0, and then when you put there this t equal to 0, then VC equal to V, and you find that k comes out to be log V. And putting this value in the circuit, putting this value into this equation, finally you get VC by V equal to this one, and that can be put in this form. So here again, if you see, the discharging of this equation is basically discharging equation. You can call that how the capacitor discharges, and this is the current during discharging. So if you wish to plot the discharging with time, so this is VC, and as you see at time t equal to 0 in this equation, if you put time t equal to 0, it starts with V. Okay, so maximum charge which at that time t equal to 0, it was V, and it starts discharging at a certain rate, and as the time goes by, it discharges to 0 value. Okay, so as time grows to infinity, this goes to 0. And this discharge, again, if you see, there is some characteristic RC which decides the speed of discharge. Similarly, if you want to plot the value of IC, that is the current in RC circuit, with time, so at t equal to 0, again you can see the current would be V by R. So as soon as the switch is closed, the current which begins to flow is V by R. Okay, and as the time progresses, the current goes to 0. And again, if you see, this RC characteristics comes over here. So again, it is decided upon depending on the time constant, and this is what it completes discharging circuit for for the RC circuit. So we have seen how the RC circuit discharges or charges and its rigorous analysis, and we have also seen what is the meaning of time constant in RC circuits. So I'll stop here.